This video is about binomial theorem, fast revision. I will explain concepts in detailed way. Following that, I will solve a few questions from January 2023 and some questions of previous JEE Main. The basic definition of binomial theorem is how to expand a binomial expansion. X plus a whole to the power of n equal to, you write that nc0 x power n plus nc1, you decrease the powers of x 1 by 1 and increase the powers of a 1 by 1 plus nc2 x to the power of n minus 2 a square plus and so on. We can write the general term like this, NCR. You see NC1 means x to the power of n minus 1, NCR x to the power of n minus r, a to the power of r, plus and so on, plus last term is NCN, a to the power of n. This binomial expansion is valid here, n belongs to n for natural number n. We observe that this is known as a general term. This is known as a general term. And this general term is denoted by TR plus 1. Means it is R plus 1th term. Remember 0, 1, 2 and R. So it is a R plus 1th term. TR plus 1 equal to R plus 1 term in x plus a whole to the power of n. So therefore, I can write that TR plus 1 equal to, the general term is NCR x to the power of n minus r, a to the power of r. It is very, very important. This is very, very important general term of binomial expansion. So therefore, we can write that binomial expansion x plus a whole power n equal to this entire sum I will write in sigma format. Sigma r equal to 0 to n. There are n plus 1 terms. This general term NCR x to the power of n minus r, a power r. Or we can also write it as r equal to 0 to n, NCR. We can write a first, next x also. So you can write here x power r, a to the power of n minus r. Therefore, the coefficient of x to the power of r, in the binomial expansion x plus a whole to the power of n is equal to, you see, NCR a to the power of n minus r. So what do we call here? NC0, NC1, NC2, NCR, and so on, NCR. These are known as binomial coefficients. These are known as binomial coefficients. So the fourth point is NC0, NC1, NC2, and so on, NCN are known as binomial coefficients. Binomial coefficients. Binomial coefficients. Fifth point is NCR formula, even though everybody knows well about this, but still I am writing n factorial by r factorial, n minus r factorial. Also, I will write a few points about this. NCR equal to NC n minus r. Seventh point is means binomial coefficients from beginning and ending are equal. We have another identity that NCR minus 1 plus NCR equal to n plus 1 CR. I am not going to prove this identity. My aim is to just revision binomial theorem very fastly along with examples. NCR by NCR minus 1 equal to n minus r plus 1 by r. The point number 8 is how to expand x minus a whole power n. X minus a whole power n, we will get the terms positive and negative alternately. This is NC0 x power n minus NC1 x to the power of n minus 1, same as first one, plus NC2 x to the power of n minus 2 a square, plus and so on, here minus of course. So what will be the general term? Minus 1 whole to the power of r, NCR, x to the power of n minus r, a to the power of r, plus and so on. At the last term is minus 1 whole power n, NCn into a to the power of n. In the format of sigma, we can write, see this is the general term. So we can write sigma r equal to 0 to n minus 1 whole power r NCR x to the power of n minus r into a power r. This is the expansion of x minus a whole to the power of n, where we assume that n is a natural number. The ninth point is how do we expand 1 plus x whole to the power of n. So here you see, in this expansion, just substitute a equal to 1. In this expansion, substitute a equal to 1. So 1 plus x whole power n, this expansion is very, very important, that NC0 plus NC1 into x plus NC2 into x square plus and so on. You can write the general term NCR x power r plus and so on. Last term is NCn into x to the power of n. Here the powers of x in increasing order. If you want, you can write in decreasing order also. So in sigma format, sigma NCR x to the power of r. So here the coefficient of x power r, the coefficient of x power r in the expansion 1 plus x whole power n. It is very, very important, is simply NCR. Similarly, 1 minus x whole to the power of n equal to, you will get alternate signs, minus 1 whole power r NCR x to the power of r. Here r equal to 0 to n. Here also r equal to 0 to n. And here the coefficient of x power r is, the coefficient of x power r is x power r in 1 minus x whole power n is minus 1 whole power r into NCR. Now the very most important one is, how do we find out the coefficient of x power k in a particular binomial expansion? So this particular one is very, very important. To find the coefficient of x power k in ax power p plus b by x power q whole power n. This is very, very important. Please try to understand properly. Here n belongs to n. P comma q both are positive rational numbers. So in binomial expansion, every time we need to write the general term. So what is the general term here? The general term is TR plus 1 equal to NCR A x power P whole power. You can write power R or you can write n minus R, no problem at all. B by x power Q whole power R. This, after simplification, you see NCR A to the power of n minus R, it is constant, and B power A power n minus R into P. Here x power Q, when it's going into numerator, it becomes x to the power of minus QR into x to the power of 1 minute. Here a to the power of n minus r is there. X to the power of p into n minus r. X to the power of p into n minus r. This is the first one. This is the second one. And into b power r is there. So this gives us NCR a to the power of n minus r, b power r, this is entirely constant, into what is the total x power. X power is here, that np minus r into p plus q. We want that coefficient of x power k. So to get coefficient of x power k, this power must be equal to k. we must have NP minus R into P plus Q equal to K. This implies we want to find out R because at which term the coefficient of x power K will occur. So here R equal to NP minus K by P plus Q. So here coefficient of x power K exists. Coefficient of x power K will exist if this expression is an integer. NP minus K by P plus Q is a natural number, or you can say it is a natural number union set 0. So remember, this formula is very, very important. It will save much time in solving of these type of questions. R equal to NP minus K by P plus Q. Now, how to find out the constant term? Constant term means x power 0, coefficient of x power 0. So for that, K must be equal to 0. So to find constant term, or term independent of x, or the term independent of x. Term independent of x in that expansion ax power p plus b by x power q whole power n. We must have, see here we want to find out the constant term, means coefficient of x power 0. So K must be 0. We must have R equal to NP by P plus Q. Here K equal to 0. K equal to 0. Term independent of x means coefficient of x power 0. So these are the basic and very, very important to solve questions which has been asked in previous JMA. Now I am going to explain a few questions using these concepts. So here are a few questions. Binomial theorem, January session. See here, let the sum of coefficients of the first three terms in the expansion of x minus 3 by x square whole power n, x not equal 0, n belongs to n, be 376. Then what is the coefficient of x power 4? So in order to find out the value of n, one condition is given, sum of coefficients of first three terms. Sum of coefficients of first three terms. So the first term is NC naught, sum of coefficients. See, I'll write that x minus 3 by x square whole power n equal to NC naught x power n minus NC1 x to the power of n minus 1 3 by x square power 1 plus NC2 x to the power of n minus 2 3 by x square whole to the power of 2 minus, and so on. Sum of coefficients of first three terms. So here, sum of coefficients of first three terms means NC naught. So here NC naught minus NC1 into 3 to the power of 1 minus 3 into NC1 plus 3 square into NC2 equal to given as 376. 376. So these are the coefficients. So now we need to solve n fast. NC0 is 1 minus NC1 is nothing but n, 3n plus 9 into NC2 is nothing but n into n minus 1 by 2 factorial equal to 376. This gives us, multiply with 2, you will get 2 minus 6n plus 9n square minus 9n equal to 2 times of 376 into 2. After simplification, so you will get after simplification of this expression, it may take a few seconds, but still I am writing 3n square minus 5n minus 250 equal to 0. So after factorization, you will get n minus 10 into 3n plus 25. Anyway, n is a positive integer, so we get n equal to 10. So therefore, we got n equal to 10, but still problem is not finished. We need to find out the coefficient of x power 4. So using this concept that r equal to np minus k by p plus q, now we can find the value of r at which the coefficient of x power k occurs. So here k equal to find coefficient of x power k, to find coefficient of x power k, x power 4, r equal to, here n value is 10, p value is here x power is 1, np minus k, k value is 4, by p plus q, p is 1, and here q value is 2. So this is equal to 2. So x power 4 coefficient occurs when r equal to 2. R equal to 2 means 0, 1, 2. That is at third term. At third term. So therefore, coefficient of x power 4 equal to, we have to write 10c2. 10c2. Here 1, here x coefficient is 1. So 1 power 8 minus 3 whole to the power of 2. So on simplification, you will get here this is equal to 10c2 is 45 into 9. This is equal to 9 5 40, 4, 36. You will get 405. So the coefficient of x power 4 in this expansion is 405. Now move to next question. Here you see AR is the coefficient of x to the power of 10 minus r in the binomial expansion of 1 plus x whole power 10. Then what is sigma r equal to 1 to 10 r cube into AR by AR minus 1 whole square. Now observe that 1 plus x whole power 10 expansion. 1 plus x whole to the power of 10 equal to, I can write that 10c0 plus 10c1x plus and so on 10c10 x to the power of 10. So AR is the coefficient of x to the power of 10 minus r, right? So therefore AR equal to coefficient of x to the power of 10 minus r. This is nothing but simply 10cr. So AR equal to 10cr. Now we need to find out what is AR by AR minus 1. So AR by AR minus 1 equal to 10cr by 10cr minus 1. Either you can expand these two binomial expansions or you can use direct formula that n minus r, here n is 10 minus r plus 1 by r. n minus r plus 1 by r. So this is equal to 11 minus r by r. Now substitute in the given sigma. So here you see sigma r equal to 1 to 10 r cube into AR by AR minus 1 whole square equal to sigma r equal to 1 to 10 r cube into this AR by AR minus 1 is 11 minus r by r and whole square is there. So 11 minus r whole square whole by r square. This gives us 1 r square will be cancelled. Sigma r equal to 1 to 10 r into, we must expand this 121 minus 22r plus r square. So now we have to apply that. This is equal to, again I'm writing, assume this sum is sum s equal to. So therefore s equal to, you write 121 outside, 121 into sigma r equal to 1 to 10 r minus 22 into sigma r square r equal to 1 to 10 plus sigma r cube r equal to 1 to 10. So the only part is left is we must aware of sigma r and sigma r square and sigma r cube formulas. So I'll write here that sigma r equal to 1 to n. Sum of first n natural numbers is n into n plus 1 by 2. And sigma r square, sum of squares of first n natural numbers is n into n plus 1 into 2n plus 1 whole by 6. Sigma r cube equal to 1 to n. It is n into n plus 1 by 2 whole square. So please be prepared all the formulas, then only we can solve the questions. So by substituting n equal to 10 in each formula and after simplification, you will get 1210. So the simplification part is left to the student. So this answer is 1210. So here we have used that NCR by NCR minus 1 formula, n minus r plus 1 by r, and sigma r square, sigma r cube. So this question is simple. Coming to the next question. Here you see, in January session, they have asked two similar questions. Both are almost all same. So I will solve only one question and rest will be given to students. So here I'm going to solve the first question. If the coefficient of x power 9 in this expansion, right? So part 1, here I am writing part 1. This is part 1. This is part 2. So for part 1, we need to find out coefficient of x power 9, right? So here k equal to 9 and p equal to 3, q equal to x power 1 is there here, x power 1. And what is n value? N value is 11. So at what position that coefficient of x power 9 will exist? R equal to np minus k by p plus q. This is the formula. So this is equal to np is 33 minus k is 9 whole by p plus q is 4. Right? So this is 24 by 4. So R value is 6. So for part 1, what is the coefficient of x power 9? Coefficient of x to the power of 9 in part 1 equal to R value is 6. So here n value is 11. So you can write 11c is 6. And what is the x cube coefficient here? Alpha. So you can write alpha power 11 minus 6 is 5. And the other coefficient is 1 by beta. We need to take only coefficient of x power 9. Right. 1 by beta whole to the power of 6. This is part 1. Now for part 2. See, we need to find out coefficient of x power 9 minus 9. So here k equal to minus 9. P value is 1. Here because alpha into x power 1. Q value is 3. And of course n is 11. So applying the same formula, R equal to NP. NP is 11. Minus Q means minus of minus plus 9 by 4. So here R value is 5. Right? So therefore coefficient of x to the power of minus 9 equal to, we will write that 11c5. In the second binomial expansion, x coefficient is alpha. So here alpha power 6, 11 minus 5, minus 1 by beta whole to the power of 5. Given that these two coefficients are equal, So these two coefficients are equal. So therefore, we have to equate both the coefficients. 11c6 alpha power 5 beta power minus 6 equal 11c5 alpha power 6. Here minus sign is there. So minus beta power minus 5. Now remember, NC R equal to NC n minus R. So using this concept, 11C6 is same as 11C5. So we can cancel these two. This implies, here you see alpha power 5 will be cancelled and beta power minus 5 is cancelled. Here one beta power minus 1 is left. This is equal to minus alpha. This implies alpha into beta equal to minus 1. But they are asking what is alpha into beta whole square. So this implies alpha beta whole square equal to, you will get 1. In the similar fashion, you can solve the second question. See, they have asked two similar questions. So here is another question on coefficients. Let the coefficients of 3 consecutive terms. This model is also very, very important. 3 consecutive terms. In the binomial expansion of 1 plus 2x whole power n, be in the ratio 2:5:8. Then the coefficient of the term which is in the middle of these 3 terms, which is in the middle of these 3 terms, means in these 3 consecutive terms, what is the middle term? They are asking coefficient. So here you see, what is the general term? The general term is, we know that TR plus 1 equal to NCR, right? 1 power n minus R, and it is 2x whole to the power of R. We want 3 consecutive terms. So let the 3 consecutive terms, wherever you start, increase 1 by 1. Let the 3 consecutive terms be in any manner. You can take that TR plus 1, TR plus 2, R and TR plus 3. These are the terms, right? 3 consecutive terms. Here what is given, that they are in, their coefficients are in ratio 2:5, right? So here coefficient of TR plus 1, coefficient of TR plus 1 by coefficient of TR plus 2, given as 2/5, and right, or I'll simplify this. This implies, so what is the coefficient of TR plus 1? Here you see, except this x power, you have to write each and everything. So NCR 2 to the power of R whole by NCR plus 1 2 to the power of R plus 1 equal to 2/5. Once again, we have to use the formula that NCR by NCR minus 1. Here I'll write NCR by NCR minus 1 equal to N minus R plus 1 by R. This is very, very important. So using the same concept, here you see R and R minus 1 means lower index is smaller than numerator 1. So this implies 2 power R will be cancelled. I'm just taking this reverse. 5/4 equal to 2 power r will be cancelled. 1, 2 is left. Bring here. 4 by 5 taking reverse. 5 by 4 equal to NCR plus 1 by NCR. This is equal to N minus, in place of R here R plus 1 is there, minus plus 1 by, here I'll write R plus 1. This is NCR by NCR minus 1, but here NCR plus 1 by NCR. So let us simplify this. This gives us, just do the cross multiplication, 5R plus 5 equal to 4 times of N minus 4R. Anyway, here minus 1 plus 1 cancel. This implies 9R plus 5 equal to 4N. So this is one relation. Now for other relation, you see, we have to take the ratio of next two terms. Similarly, coefficient of TR plus 2, coefficient of TR plus 2 by coefficient of TR plus 3 equal to, it is 5 by 8. So this implies TR plus 2 is nothing but NCR plus 1, 2 to the power of R plus 1 by TR plus 3, NCR plus 2, 2 to the power of R plus 2 equal to 5 by 8. Implies, this gives us, same as before one, here 2 power R plus 1 cancelled, right? Here 2 power R plus 1 cancelled, and 1 by 2 is left. Okay. So I am taking in reverse, NCR plus 2 by NCR plus 1 equal to, here 1 2 is left, you cancel 2 4s, so you will get 4 by 5. So therefore, using above the same formula, we get here, you see, N minus, in place of R we have R plus 2, N minus of R plus 2 plus 1 by, you have to choose the bigger one, R plus 2 equal to 4 by 5. This implies, just do the cross multiplication, 5N minus 5R. This is minus 2 plus 1 means minus 5 after multiplying by 5 equal to 4R plus 8. This implies 9R plus 13 equal to 5N. This is number 2. So here is one equation and here is another equation in terms of N and R. So by solving these two, we can find the value of R as well as value of N. So just simply subtract one equation from the other. Simply we can do that, equation 2 minus equation 1. We will get 9R will be cancelled. See, 9R will be cancelled. 13 minus 5 is 8 equal to 5N minus 4N is N. So therefore, N value is 8. Substituting any one of 1 or 2, we will get R value. So put in equation 1, put in 1, we get 9r plus 5 equal to 40, 32. This implies you will get r value equal to 3. So now what is the question? You observe. They are asking that middle of these three terms. So middle of these three terms means the coefficient of middle of these three terms means the coefficient of TR plus 2. The coefficient of TR plus 2. Right? So coefficient in TR plus 2. The coefficient in TR plus 2. That is T5 is, here n value is 8. So 8C4 into 2 to the power of 4. 2 to the power of 4, because given expansion is 1 plus 2x whole power 8. So that's it. We have to multiply this, that 8 into 7 into 6 into 5 by 24 into 16. So this, after simplification, you will get 1120. So in each and every question, we are using only the general term, means coefficients. So once you understand the expansion of x plus a whole power n proper way, then no doubt every question you can solve in the same method. Going to next question. Here is another question. One question asked in 30th January 2023, and similar question I found in June 2022, shift 2. So I will solve either of questions. Here your first observation is, in both the sequences, the terms are in GP. This is the first term. Second term by first term, the ratio you will get x by 1 plus x. Third term by second term, again you will get x by 1 plus x. So common ratio is x by 1 plus x. So here these terms are in GP, right? So this is in GP. So what is the formula for sum of n terms of GP? S equal to A plus AR plus AR square plus and so on, AR to the power of n minus 1. There are n terms. This is equal to A into 1 minus R power n by 1 minus R. Of course, R not equal to 1. So this is the formula to find sum of n terms of GP. Right? So in question number 6, what is the common ratio? Common ratio equal to second term. Second term is x into 1 plus x whole to the power of 499 by first term 1 plus x whole to the power of 500. After simplification, you will get x by 1 plus x. So this is the common ratio. And what is the first term? A is the first term, that is 1 plus x whole to the power of 500. Next one is, how many terms are there? You just count it. You see, this is 500, or you can say here x power 0, x power 1, x power 2, x power 500. So number starts from 1, 0, 0, 1, 2, 3, and so on up to 500. So there are 501 terms, n equal to 501. Now task becomes very simple. So the given expansion s equal to use this concept a into a is nothing but here 1 plus x whole to the power of 500 into 1 minus r value is here x by 1 plus x power what is n value 501 whole by 1 minus x by 1 plus x. So we need to simplify this. This is equal to 1 plus x power 500. Here you have to take LCM. 1 plus x whole to the power of 501 minus x to the power of 501, right, whole by 1 plus x whole to the power of 501 into, we need to simplify this denominator. This gives 1 plus x by, after simplification, simply you will get 1. This is 501. So this is equal to, remember, 1 plus x into 1 plus x whole power 500 is 501. So this term will be cancelled. 1 plus x whole power 501. Here 1 plus x, here 1 plus x whole power 500. So s equal to 1 plus x power 501 minus x to the power of 501. Now what do you want to find out? Go back to the question. Here you see, we need to find out the coefficient of x power 301. So the coefficient of x power 301, the coefficient of x power 301 in S equal to coefficient of x power 301 in 1 plus x whole power 501. That is 501 C 301. Or you can write 501 C 501 minus 301 is 200. So either of this. There is another question based on coefficient of x power k in ax power p plus b by x power q whole power n. Here you see. They are asking this time in different way. Let alpha greater than 0 be the smallest number such that in this expansion beta into x to the power of minus alpha exists. Then what is alpha? Right? So we need to find out that x power minus alpha exists. Right? So to find coefficient of x to the power of minus alpha. Here alpha is positive. Right? So what is our formula? R equal to np minus k by p plus q. Every time we will use this formula. Right. So this is equal to, here what is n value? 30. So n equal to 30. P value is 2 by 3. So into 2 by 3 minus, here k is nothing but minus alpha. So you will get plus alpha whole by, what is q value? 3. So p plus q is nothing but 2 by 3 plus 3. This gives 20 plus alpha after simplification into 3 by, you will get 3 3s 9 plus 2 11. So here R is an integer. R is an integer, right? So R belongs to Z. Here, in fact, this is a natural number. So for what value of alpha you will get, R will be a natural number. Here 20 plus alpha must be divisible by 11, right? So since R belongs to natural number, therefore 20 plus alpha must be divisible by 11. Means it must be 11 into some natural number k. So very simple. That 11 into 1, 11, 11 into 2, 22, right? So 11 into 2 equal to 22, right? So therefore, you will get alpha equal to 2. 11 into 3 equal to 33, like this. So you won't get alpha is a, here, what is alpha? Alpha equal to 11 into 3, 33. 33 minus 20, 30. Next, 11 into 4 equal to 44. So you will get here alpha value is equal to 44 minus 20 means you will get alpha equal to 24, etc. We want that only smallest number, smallest number. So therefore, the smallest alpha greater than 0 is 2. That's it. Answer is over. So there are several questions that they may ask that how many values of alpha exist for which beta into x power minus alpha is possible. Then we need to give another that you can say that 11 into 5 equal to. But here, based on this, we need to find out, I forget to tell you, here R always lies between 0 to 30. So R should not exceed 30. So for this particular reason, what is the R value? R equal to, right? When alpha is, so this is 2. 2 into 3, R value is 6. Here, what is R value, right? It is 3. 3 into 3, 9. And here, what is R value? Here, what is R value? When you are substituting alpha 24, 44 by 11, 4, 4 into 3, 12, like this, you need to count the value of R. R simply, this value always lies between 0 to 30. So based on that, we need to find out alpha values and R values. So this is a very good question. Indirectly, they have asked that at what position this beta into x power minus alpha is possible. We can find the value of beta also. Here is another simple and basic level question. Same model. They are asking what is the coefficient of x power minus 6 in this expansion. So I'm solving this question very fast. Here m equal to 9 and p equal to, here x power 1 is there. So it is 1. Q equal to x square, right? K equal to minus 6. So R equal to NP 9 into 1 minus K means plus 6 by P plus Q. P plus Q is 3. So R value is 5. That's it, over. So therefore, the coefficient of x power minus 6 equal to, here r value is 5, so n is 9, 9c5. Okay, what is the x coefficient here? 4 by 5. So 4 by 5. Power 9 minus 5 is nothing but 4. Here 5 by 2, second one, 5 by 2, whole to the power of remaining power is 5. So it is your task to simplify this. Here is another question asked on 31st January 2023. If the constant term means term independent of x, or you can say coefficient of x power 0. In the binomial expansion is minus 84, and the coefficient of x power minus 3l is 2 power alpha into beta, where beta is less than 0 is an odd number. So too many constraints are there. Then asking what is modulus of alpha L minus beta. This question also comes under similar model. So here n is 9 and p value is 5 by 2. Q is L. I am assuming L greater than 0, right? Assume L greater than 0. Let us see what will happen. And K equal to minus 3L. K is. So we have the similar formula that R equal to NP minus K by P plus Q. N is 9 into 5 by 2 minus K means you will get 3L by P plus Q, which means that 5 by 2 plus L. So we need to simplify this. This gives us 45 plus 6L whole by 5 plus 2L. So here R must be a natural number, right? Here you see, I have taken mistaken. This is mistake. So we want to find out constant term in this binomial expansion is minus 84. So remove this part. So here K equal to 0. Because we need to find out K equal to 0. Because we want to find out constant term. So here this term won't be there. This is 0. Minus here. So you will get 45 by 5 plus 2L. Right. And given that independent term coefficient is minus 84. Right. So here given that coefficient of x power 0 equal to term independent of x, right, equal to minus 84. So which means that it happens at r plus 1 term. So 9CR, this is 1 by 2 whole to the power of 9 minus r, right, coefficient of x power 0. And minus 4 whole to the power of R. Given that this is equal to minus 84 for this particular value of R. We need to find out for which value of L this R is possible. In fact, we can substitute L equal to 1, 2, 3, 4, 5, 6, and so on, but it takes little time. So let us find out what is the value of R if possible. Right. So this implies 9CR. This is 1 by 2 power 9 minus R minus 1 whole to the power of R. And here this is 2 to the power of 2R equal to minus 84. So here minus sign is there. So R must be odd. R must be odd. So this gives us 9CR minus 1 whole to the power of R. Here I am writing 2 to the power of this 3R minus 9. So minus 84 we must write as 2 power something into some number. So this is 21 into 4. So minus 21 into 4 is nothing but 2 square. So here you see, if I equate 3R minus 9 equal to 2, then you will get R equal to 11 by 3. This is not possible, right? So this is not possible. So what should I do now? We have to adjust right side expression in such a way that R must be integer. So 2 to the power of 3R minus 9 equal to, I will write multiply another 2 minus 42, or you can say that this is to minus 21 by 2 into 2 to the power of 3. Or just wait. Anyway, this binomial coefficient is never fraction. So I'll take this as a 2 to the power of 1. And this is minus 42. So therefore, now equate this power. 3R minus 9 equal to 1. Right? So this implies R equal to, you will get 10 by 3. So this is also not possible. Now there is another chance that this is also not possible. Remember? So 9CR into minus 1 whole power of 2 to the power of 3R minus 9 equal to, you have to take that minus 84 into 2 to the power of 0. So therefore, 3R minus 9 equal to 0 implies R equal to 3. And we have to check that L must exist. So here you see, substitute here. So R values, this is 45 by 5 plus 4L. R equal to 45 by 5 plus 4L. So this implies 3 equal to 45 by 4, 5 plus 4L. So you will get L value equal to 5. L value equal to 5. For L equal to 5, you will get R equal to 3. R at the beginning, we can substitute. Here you see, if R equal to, if L equal to 1, what is R value? 45 by 9. Right? This is equal to 5. But you must see that will exist or not. L equal to 2. R is not an integer. For L equal to 3, R is not an integer. For L equal to 4, R is not an integer because 16 plus 5, 21. For L equal to 5 and R equal to 3. Like this, we can verify it. Now what else is remain? Go back to the question. The coefficient of x to the power of minus 3L we want to find out. The coefficient of x to the power of minus 3L. Well, the coefficient of x power minus 3L, the coefficient of x power minus 3L in so here the coefficient of x to the power of minus 15 in x to the power of 5 by 2 whole by 2 minus 4 by x to the power of 5 whole to the power of 9. Okay, we want to find out this. For this, we need to find out the value of R again. R equal to NP, N is 9, P is 5 by 2, minus K, K is nothing but here, minus 15, so minus of minus, plus 15, by P plus Q, that is 5 by 2, plus 5. So this is equal to, you will get 5 will be cancelled, or 45 plus 30, 75, whole by 15. This is equal to R value is 5. So this is equal to 9C5 1 by 2 power 4 minus 4 whole to the power of 5. This we need to convert into some format that this is equal to, here you see 2 power alpha into beta, where beta is less than 0, an odd number. Beta is less than 0, an odd number. So this is equal to 9C5 is nothing but 9C4 1 by 2 to the power of 4 into minus 2 to the power of 10. So this is equal to negative of 9 into 8 into 7 into 6 by 4 factorial 24 into 2 to the power of 6. So this is 6 fours and 4 twos. So this is equal to minus 63 into 2 to the power of 7. There ends the matter. So now you can understand that this is beta into 2 to the power of alpha. So therefore, beta equal to 63 minus 63 and alpha equal to 7. Substitute these values, you will get the answer. So I'm leaving the rest of the questions for you. You can use the same method if the term without x means this is coefficient of x power 0. Similar method, right? Coefficient of x power 0 is 7315. Then what is mod alpha? So again, I am applying here that R equal to NP. N is 22. P is nothing but 2 by 3. K is 0. So whole by P plus Q 2 by 3 plus 3 equal to 44 whole by 11. This is equal to 4. So here R is 4. So the term without x is nothing but now term without x. The term without x is nothing but term independent of x. The term without x equal to 22C4 into here x power 2 by 3 coefficient is 1. So 1 to the power of 18 and alpha power 4 given as 7315. So it is just a simplification that it is 22 into 21 into 20 into 19 whole by 24 into alpha power 4 equal to 7315. So this gives us, after simplification, you will get alpha power 4 equal to 1 implies alpha equal to plus or minus 1. But they are asking what is mod alpha. Hence, mod alpha equal to 1. So go to the next question. Let the sixth term in the binomial expansion of root over 2 to the power of log of 10 minus 3 power x base 2 plus fifth root of 2 to the power of x minus 2 into log 3 base 2 whole power m in increasing powers of 2 to the power of x minus 2 into log 3 base 2 be 21. If the binomial coefficients of second, third, fourth terms in the expansion are respectively first, third, fifth terms of AP, then the sum of the squares of all the possible values of x is. So here the first basic point is we have to use simple logarithmic identities. A to the power of log b base a equal to b. Of course, there are conditions a greater than 0 base, a not equal to 1, and b also must be positive. So we have to simplify here the term by term. Root over 2 to the power of log of 10 minus 3 power x base 2. So this gives simply here you see root over 10 minus 3 power x. Nothing but 10 minus 3 power x whole power 1 by 2. This is the first term. What is the second term? Fifth root of 2 to the power of x minus 2 into log of 3 base 2. So this we will write that 2 to the power of, here x minus 2 you write as a power of 3. log of 3 power x minus 2 base 2 whole power 1 by 5. So this is equal to, again using the same formula, a power log b base a equal to b. So here you will get 3 power x minus 2. 3 power x minus 2 power 1 by 5 is nothing but this. So here the sixth term in the binomial expansion in increasing powers of this is given as a 21. Sixth term is nothing but T6 equal to 21, which means that here MC5, this is the first term, so 10 minus 3 to the power of x whole to the power of m minus 5 by 2, because here by 2 is there, and the second one is into 3 to the power of x minus 2 by 5 whole to the power of 5, given as 21. So we must simplify this. MC5 10 minus 3 power x whole to the power of m minus 5 by 2 into 3 to the power of x minus 2 equal to 21. What else we need to find out? We need to find out the value of m. So to find the value of m here, if the binomial coefficients of second, third, and fourth, second, third, and fourth terms in the expansion respectively, first, third, fifth terms of AP. So we need to find out the value m using this information. MC first, second term is MC1, coefficient in second term MC1, and third term MC2, and fourth term MC3, right? These are in AP, belongs to AP. And in AP they have given see first, third, and fifth term. So this is the first term, and this is the fifth term, third term, and this is the fifth term. So here A equal to MC1, M, A plus 2D equal to MC2, and A plus 4D equal to MC3. So we have to solve for M, then problem will be over. So subtract this middle equation from the third equation. MC3 minus MC2 equal to, you will get 2D. Right. So therefore, here A is M. So M plus MC2, 2D is MC3 minus MC2 equal to MC. So directly we can write that ABC are in AP, then 2B equal to A plus C. So here MC1 plus MC3 equal to 2 times of MC2. After simplification, you will get M value is as a 7. After simplification, you will get M value as a 7. If you want, I will solve this question. M plus M into M minus 1 into M minus 2 by 6 equal to m into m minus 1. So here one m will be cancelled like this. So this implies 6 plus m square minus 3m plus 2 equal to 6m minus 6. This gives us m square minus 9m. This is plus 14. So this is 2 into 7. So we can write that m minus 2 into m minus 7. M equal to 2 is rejected. M equal to 2 is rejected because those terms will not exist. That MC1, MC2, MC3 means if M is 2, the expansion will have only 3 terms, 0, 1, 2. So M equal to 7 is possible case. So substituting here, therefore 7C5, 10 minus 3 to the power of x whole square. This is 7 minus 5, 2 by 2. This is power 1 into 3 to the power of x minus 2 equal to 21. So 7C5 is nothing but 7C2. So this value is 21. So this is cancelled. This implies 10 into 3 to the power of x minus 2 minus 3 to the power of 2x minus 2 equal to 1. After simplification, simplification is nothing but bring this term this side. So I can write 3 to the power of minus 2 as 1 by 9, 3 power x whole square minus this is 10 by 9 into 3 power x plus 1 equal to 0. So you will get a quadratic in terms of 3 power x whole square minus 10 into 3 power x plus 9 equal to 0. So this can be written as 9 into 1, of course, minus 9 into minus 1. So again factorization, it becomes 3 power x minus 1 into 3 power x minus 9 equal to 0. So 3 power x equal to 1 or 3 power x equal to 9. This implies the possible values of x are 0 or x equal to 2. So what is the given question? Given question is then sum of all squares of possible values of x. Sum of squares of all possible values of x is sum of squares. Sum of squares equal to 0 plus 2 square, that's equal to 4. Thank you. We'll see you in the next video.